This is the HOTA S6 Pro, and if you're looking for a massively powerful, massively feature-packed, all-in-one LiPo charger, this might just be the one for you. I'm Joshua Bardwell, and you're going to learn something today. I want to start this video by acknowledging the HobbyMate D6 Pro, which has been my favorite charger pretty much since it first came out and I got one. I bought 4 of these over the years, and all of them are still going, except one of them I broke the screen on it. Okay, so that's my fault, not theirs. And this is part of the reason why you haven't seen me review as many LiPo chargers as have come out in those years, because every time I see a new LiPo charger, I think, I would still take the HOTA, HobbyMate, HOTA, HobbyMate, same, not the same company, but they're made in they're the same. They're the same. Don't let that get you confused. But the HOTA S6 brings something new to the table that I think makes it worth a look. And what it brings to the table is even more power and a couple of other features that some of you are going to really like. Let's compare the HOTA S6 to the D6 Pro and this, the ToolkitRC M6D AC. And what all 3 of these chargers have in common is that they have a built-in power supply. So every charger needs a DC power supply to take the AC mains voltage out of the wall, convert it to DC, and then use that to charge the battery. Sometimes you can power a charger directly off a DC source, like if you were to plug it into your car's 12-volt adapter. That's a DC source. But most of the time, we're running these chargers off an AC source, and a power supply has to convert that to DC. So if we look at the back of each of these chargers, we'll see they have a plug to plug into the wall. The one on the S6 is a super big, beefy plug, whereas the others are a little bit smaller, and they have a built-in power supply, and that power supply is going to be the limit on how much output power they can push. So we can see here that the ToolkitRC is rated for 200 watts when it's powered from AC. The D6 Pro is rated for 200 watts when it's powered from AC, and the HOTA S6 is rated for 400 watts when it's powered from AC. And that is part of what makes the S6 so notable, because that's one of the biggest built-in power supplies of any charger I'm aware of that has a built-in power supply. I can think of 1 or 2 with a bigger power supply, but they are much larger overall, and that's part of what makes the S6 so special. It is a 400 watt capable charger that is completely self-contained, relatively compact, not as compact as the D6 Duo or the ToolkitRC. It's bigger, but relatively compact, and to have that much charging power in one relatively compact unit is definitely notable. Let's go ahead and plug this guy in and power it up. We'll take a look at the menus and the features. You can see that it uses a standard PC style plug. I don't remember the exact name of this format, but it is a big, beefy, honkin' plug, 3-prong, and can carry a lot of current. Now, if you're familiar with the HobbyMate or HOTA menu system, there's not going to be a lot of surprises here, but we're going to go through it anyway because it wouldn't be a good review if I didn't. And that'll give us a good opportunity to run down some of the features that this charger has. So this is a 2-channel charger. There's 2 ports here on the front. You can charge 2 batteries at a time. And the first thing you're going to do is use this button to select either channel 1 or channel 2. Once you've selected the channel, we can click this jog wheel on the top to go into the menu, and we can see the tasks that the charger supports. Charge means that we're going to charge the battery. Discharge means that we're going to discharge the battery. I think it takes it all the way down to like 3.0 volts. Let's just double check that. If we choose discharge, what's the minimum voltage we can choose? No, 3.5. So it'll only take it down to 3.5. It won't fully kill the battery. External discharge, the way that works is you unplug the battery or the charger from the wall. You have a battery that you want to run down, and you want to run it down quicker than just doing the storage setting on the charger. So you plug that into the back of the charger, and then you've got a load resistor like this. This is a wire wound resistor. It can support about 200 watts, and it's about a 2 ohm resistor. And you plug that in. Oh, darn, I need an adapter wire. I don't have the right cable there. Well, you plug that into the output side, and the charger pulls current from the battery here and runs it through the load resistor, which converts it into heat. Basically, the external discharge lets you run a battery down faster by using a great big external resistor as opposed to the little tiny discharge resistors that are built into here. It's a very special use case, but if you've got a lot of batteries or very big batteries that you want to run down, it can be handy. Storage program will run your batteries down to storage voltage. For LiPos, that's 3.8 volts. It'll either charge them up or run them down. The discharge is, as I said previously, it's going to be pretty slow if it's a very big battery, but it will get them there eventually. And then balance program balances the cells of the battery. This is something that the charger will do at the end of every charge cycle anyway. The charge program does balance at the end, but the balance program balances the battery at whatever voltage it's currently at without charging it up first. And to tell you the truth, I'm not really sure what the point of that would be, but there you go. Finally, there is the power supply function. So this unit can act as a DC power supply. It has a DC power supply built in. So if you needed just 12 volts DC or 18 volts DC to run some other appliance, you could get an XT60 to barrel jack plug or whatever other kind of plug or adapter you needed and use this as a power supply. That's pretty cool. When using the power supply task, we can set the output voltage anywhere from 5 to 29 volts, and it does have an amp limit anywhere between 15 and I believe 1 amp is, oh no, all the way down to 0.1 amps. That's actually pretty impressive. I wasn't expecting it to get that fine-grained. That output current limit lets you protect against, it's kind of like a built-in smoke stopper. If you short circuit or if the device tries to pull too much current, it will shut it down and prevent it from frying things. And you can also have a maximum output power limit if you want to specify the output power in watts. When charging batteries, we have the option to charge several different kinds of batteries, including high-volt lithium batteries, regular LiPos, lithium ion, and LiFe, lithium iron phosphate, as well as, I guess this is just generic lithium, and you set the end voltage. The only real difference of these is the end voltage. For high volt, it's 4.35. For LiPo, it's 4.2. For lithium ion, I believe it's 4.10. I don't remember what lithium iron phosphate is. That's why it's there in the menu. And we can also charge nickel zinc and lead acid batteries. Now, those are the program settings of the charger. There are also some system-wide settings, and one of them is going to be to turn off this gosh darn beep that is driving me freaking crazy. So to access that, you long press the menu button, and you can change the task parameters. Task parameters include a safety timer. The safety timer will prevent, if the charging cycle goes on longer than the safety timer, it will shut down because it's like, it shouldn't be taking this long to charge a battery. The max capacity is the same thing. By default, that is set to 99999, and basically it'll just keep charging forever. But if you know that you usually charge 1500 milliamp hour batteries, you might say, well, look, if you charge more than 3000 milliamp hours, something clearly isn't right. And it would automatically stop. You can change the end current. The end current is at the very end of the charge cycle. The charger slows down its current, and then as the battery approaches its stop voltage, 4.2 volts for a LiPo, then the charging cycle stops. And a lot of times what will happen is then the voltage will sag down just a little bit. So if you're trying to charge your batteries to 4.20 volts, when the charge cycle is done, maybe they'll be at 4.19. By setting that end current to a lower value, you can sort of trickle charge more and longer at the end of the charge cycle, which gets you closer to the end voltage, but makes your charge cycle take longer. On the other hand, you could raise the charge current, which will go faster at the end of the charge cycle, but means it's not as precise and not as close to like 4.20 volts exactly. You know, something that I might try, I haven't tried this before, but what if you were to increase the end current and also increase the end voltage? So you tell the charger, your end current is 20%. You're not going to slow down and trickle charge to the end, but you're going to shoot for 4.21 volts. And then when it sags back down, it's at 4.2 and you get a faster charge cycle. I don't know. Maybe I'm overthinking it. The system parameters are where we can turn off this damn beeping. Volume off. Okay, hallelujah. We also have the option to change the LCD backlight. The maximum input power, that's only relevant if you're using an external power supply plugged into the DC input on the back. So if you're using the built-in power supply, then the max input power shouldn't come into play. I wouldn't think. that 400 watts is just going to kick in. The minimum input voltage would be used to, if you're like running it off your car and you don't want to kill your car battery, you would set that at like 11.5 volts or whatever your safe voltage is for your car battery. If you're running it off a field charging pack, you would set that to whatever voltage your charging battery had as a minimum. Completion signal goes off. It's a beeping that goes off when the charge cycle is done, and you can have it go off one time or just keep going off forever. We're going to put that on single, and we have the option here to calibrate channels 1 and channel 2. I highly recommend you do not mess with this unless you are really sure that your charger is way out of calibration. It's actually more complicated than you think to calibrate a charger, and it's not as simple as just taking a cheap old multimeter. And I mean, if your charger doesn't match a cheap old multimeter, then something's probably wrong, because these multimeters are usually pretty accurate, but they usually don't have enough precision to actually do fine-grained calibration. So I have a video about how to calibrate a charger, the right way to do it. I'll put a link to that down in the video description. These should be pretty well calibrated from the factory though, so you probably shouldn't have to mess with this. Well, let's just take the opportunity to check that. Here I've got an ISDT cell checker. I have previously calibrated this off of a lab grade voltage reference, so I believe it's pretty accurate. 4.20 and change. Let's plug this into the HOTA and see what it reads. Well, all of them seem... Oh, no. Uh-oh. Well, let's check it with a multimeter. Let's see who's right. Ooh, 4.21. Looks like the HOTA S6 is correct. 4.20, 4.21, dead on. Well, okay, looks like the HOTA S6 is calibrated right, and my old ISDT needs to be recalibrated if I really cared about that third decimal point. But good to know. Here on the side of the unit, there's a couple other little goodies. There are two 5-volt, 2.1 amp USB outputs. That's just standard USB charging, the slow charging kind. And there is one USB-C, and this is 45 watt USB PD power delivery. This is going to fast charge your phone, and if you have something like one of those little USB powered portable soldering irons, it's going to be able to run that. It would be better if this was 65 watts. 45 watts will get those soldering irons going, but I think they max out around 65 watts. So it won't max it out, but is definitely worth a mention. Because if you go online and you look for 45 watt USB PD, just converters, you know, whatever, then just something that plugs in the wall, in other words, they will cost you $35 or $45 all by themselves. So for some people, that's going to be the killer feature that puts this charger over the top. On the back of the charger, we also have an XT60, which is 12 volts output at max 1 amp. And I'm not sure what that's going to be good for. Probably something, but couldn't you also just use the power supply feature here on the front and have more than 1 amp? Because that goes up to 15 amps. But then again, I guess the back one doesn't tie up a channel, so that's nice. Now this charger also can be powered from DC input, anywhere from 10.5 to 30 volts, and when powered from DC, it will do up to 650 watts. But I think in a lot of ways, that's missing the point of this charger. Because if you want a charger that you intend to run off of a separate DC input, like a car charger or a field charging battery pack or something like that, you can get less expensive, smaller chargers that output the same 650 watts or more of output. The real appeal of the HOTA S6, in my opinion, is for somebody who wants a self-contained unit. Like, I really love traveling with my D6 Pro because you take this and you take a power cable, you chuck it in your suitcase, and you know you've got everything you need to charge your batteries. You don't have to have a separate power supply. And I have traveled with a separate power supply, and it's not the end of the world, but it is a little bit cumbersome, and it's just one more thing to forget and take up space. So the real appeal of the S6 is somebody who wants a self-contained high-power unit that they can travel with, or that they don't have to worry about having an external power supply taking up room on the bench with cluttered wiring. If you were going to use an external power supply, that's fine, and it can do it if you chose to take it to the field or somewhere where you didn't have AC power. But in that case, you would do just as well with something smaller and maybe less expensive. Although it is nice to have these extra charging ports here, and that may put the S6 over the line for you. Is it over the line? Let's do a dollar for dollar roundup and see. HOTA S6 costs $160. It has 400 watts total output power. Now that's divided between 2 channels. So 400 watts divided by 2. That could be 400 watts on a single channel or 200 watts on either channel, or 100 and 300. You can split it up however you want. And 15 amps max output power. That is on the internal PSU running off of AC. Off of DC, it is 650 watts total. Again, and I believe that is 325 watts per channel. That is not split 2 ways. It's just 325 per channel max. Okay, let's try the D6 Pro as well. It is going to be AC 200 watts divided by 2 at 15 amps. And on DC, we've got the same. 650 watts equals 325 per channel. And we'll take the ToolkitRC M6D AC, and we get AC 200 watts. Oh, this is all looking very similar, divided by 2. And DC 700 watts equals 350 per channel. The S6 has 45 watt USB PD. The M6D AC has 65 watt. Oh, that's nice. USB PD. The D6 Pro is $120, and the M6D AC is $150. The M6D AC, I have to mention, also has a cool feature called continuous function, where you start the charge mode and it charges the battery, and then you unplug the battery and it just waits for you to plug the next battery in and automatically starts charging the battery. So if you have a bunch of batteries to charge or put to storage, that's pretty cool. It just saves you some button presses. Maybe not like a killer feature, but it is worth mentioning. So in summary, it looks like the D6 Pro has about the same specs as the M6D AC at a cheaper price. The D6 Pro has USB output, but it doesn't have USB PD, so that gives a little bit of an edge to the M6D. But the D6 Pro is $30 cheaper, and the S6 is close to the same price as the M6D AC, but has much higher AC output and a couple other little output options like USB charging and so forth that the M6D AC doesn't have. So the HOTAs seem like they have the edge, and I would recommend them over the ToolkitRC even if the price per feature was closer. And it's difficult to talk about this because it's always hard to tell when you hear about products like having reliability problems, it's hard to know whether that's just a couple of people who got a bad unit making a lot of noise or whether it's representative of a larger trend. There absolutely are people out there who rely on the ToolkitRC charger. My friend Evan Turner heads up FPV. His company 533 has a special 533 edition of this exact charger. He relies on it, and many racers I know say they use them in the field and they love them and they find them to be very reliable. Personally, I've had bad experiences with them. I can tell you that this particular unit I purchased at Rotor Riot Rampage because I accidentally went to Rotor Riot Rampage without a charger, and I had to buy one there on site. And it was miscalibrated. One of the cells was way off, like 0.3 volts or something ridiculous, and it wouldn't charge. And I had to run the calibration routine, and then it worked fine, and it's been okay. I had an M6D AC previously that they sent me to review, and I hesitated to review it, but I started using it myself, and after a little while, for no reason, one of the channels died. Just started measuring the voltage wrong and was unusable. Another person at Rotor Riot Rampage bought this exact charger. his was miscalibrated too. And since I had just been through it, I was like, hey buddy, I know what's going on. I just don't have a great feeling about ToolkitRC because when you buy lipo chargers, you want to feel confident that they're coming out of the box right. And there's just not a lot of room for mistakes with lipos. And I just don't have that feeling about them. Whereas the HobbyMate or HOTA S6 and D6 Pro, I have had 4 of these for years, and they have all been rock solid. They've taken everything I've thrown at them, no DOAs out of the box, no miscalibrated, they're just rock solid. And I just feel like, in addition to the fact that these offer more performance for the dollar, I think they're probably better chargers. There are links down below. They're affiliate links. You know what that means? This is your first time here. Affiliate links means that when you make any purchase at the affiliated vendor, after clicking that link, I get a small commission. It's an easy way for you to support the channel since it doesn't cost you anything. It just throws a couple bucks to me when you make that purchase. Click the affiliate link, make your purchase, do it before you shop at any vendors, but especially if you're going to go pick up one of these, those links are down below, and I sure do appreciate it. The only question that's remaining is, do you really need 400 watts of output power? Isn't more always better? No, because this is a much bigger and heavier unit, and it's more expensive than the D6 Pro. And many people don't need this much output power because your battery, you don't charge a battery this size at 400 watts. I've got a video where I take you through a spreadsheet that I made. Ooh, spreadsheets. We all love those, don't we? That spreadsheet lets you put in the specs for your battery and put in the specs for your charger, and it tells you if your charger is big enough to charge your battery as fast as you want to charge it. So if you're not sure, like if all these extra charging stuff here hasn't put you over the edge, then I'll put a link, I'll put a card on screen to a video where I take you through that spreadsheet, and you can go check that out. But that's going to do it for this video. Happy flying.